Hi folks, Jenny here, to discuss complex fractions. Well, they're really not so complex, and this video is to show you they're pretty darn simple. So it's all about how to divide a fraction by a fraction. Let's get started. Let's review fraction division with an example. Divide 4/5 by 6/20. Now the first thing we need to do is change division so that it's multiplication. And in doing so, we need to take the reciprocal of the second fraction. 4/5 multiplies 26. Now we look on the diagonal. 5 goes into 20 4 times. So we have a 4 left behind on the 20. And 4 and 6, they both share a factor of 2, so I'm going to cancel away the 2's. Now let's look at the resulting multiplication. We get 8/3, which is the conclusion to this fraction division problem. Now let's look at complex fractions and how those problems are very much like this problem. If you feel like you've seen this problem before, well, you pretty much have. This division sign has turned into a fraction bar, and that's pretty much the only difference between the previous problem and this problem. Again, we divide, and then we multiply, and then we get a result. So as you can see, complex fractions are really no different than the fraction division problems we just saw. In the next example, we have a fraction divided by a whole number, 2. Again, the fraction bar is indicating a division. So we have 4/5, and now we indicate that division. Divide by 2. Turn it into multiplication by multiplying by the reciprocal, and look for the diagonal division. There's a common factor of 2, which we cancel off, and then finally we multiply, and we get a result of 2/5. In our next example, we'll take the whole number 12 and divide by 4/5. Again, we note that division, write it as 12 divided by 4/5, change it into multiplication by the reciprocal, and then we look for our diagonal cancellations. We have a factor of 4 on the diagonal, so I'll cancel that off. And ultimately, I'll just have 3 times 5 is 15. Okay, now we'll look at examples that are more algebraic next. As promised, let's throw in some x variables into our complex fraction. Now we need to divide these fractions, and we handle it in the exact same manner that we did before, and first turning the division into multiplication. Now at this point we observe that on the diagonal we have some common factors. So let's have a look at the common factors of 2 here, and so let's cancel that away, and 5 here. Now notice too that the x's will cancel each other and they are gone. So the next step will be to multiply 2 times 3 for the top of the fractions, and the denominator was completely canceled away. So now we just have 1. We multiply 2 times 3 and get 6. We're done. All right, on to the next one. In this next example, we have a fraction for the numerator, but notice that the denominator is just a single algebraic expression that doesn't look like a fraction at all. Okay, well, let's divide. We have 2x squared divided by 3y, and then that is being divided by 6x. Well, we're going to handle 6x as if it were a whole number. Put a 1 under it. Now we need to multiply by the reciprocal. I see a common factor of x's here on the diagonal, as well as my numbers 2 and 6. I have a common factor of 2, so let's start with that. Common factor of 2, cancel that out. We get a 3 left behind for the 6. Now let's look at x squared. X squared is x times x, and so we get to cancel out one of those x's and we leave behind the other. It looks like we've canceled as much as we can. Well, when I multiply, I get x over 9y, and it looks like we've got it. All right, on to the next problem. Okay, this will be our last example, and we have 12h in the numerator divided clearly by a fraction. So let's write this out. 12h is divided by 3h to the third over 8. Well, I'm looking at 12h, and it doesn't look like a fraction, so I'll put a 1 under it, treat it just like a whole number. The next step is I want to turn everything into a multiplication problem. I see that I have a common factor as far as the numbers go between 12 and 3, cancel away the 3, and I'll have a 4 left for the numerator. And then I have my eye on that h here, and I have 3 h's. One of the h's cancels away with one of the h's, and now I've seen that I've canceled everything I can. I'm ready to multiply across the top. I'll say 4 times 8 is 32, and then in the denominator, I would just multiply 1 times, let's see, what do I have left here? H squared. And that's it. That's my answer. So I hope this helps you with complex fractions, and stay tuned for more great math videos.